Hello everyone. In this video tutorial, we will discuss intersection over union. Intersection or over union or IOU is an evaluation matrix that is used to measure overlap between predictions from the object detection model and actual ground truth. Okay, so now you can see that here I have just an example. Like for example, if you are detecting the stop sign or if you are doing the road sign detection using YOLO V7. Okay, so this is the ground truth bounding box. In the green color, you can see the ground truth bounding box over here. And that in the red color, you can see the predicted bounding box. So when we train our YOLO V7 model, our main goal is that is predicted bounding box should be as close as to the ground truth bounding box, or it should fit to the ground, or it should fit completely to the at the ground truth bounding box. So if our predicted bounding box fits completely at the ground truth bounding box, then we can say that IOU is equal to 1. But if this predicted bounding box does not intersect with this ground truth bounding box in green color, so in that case, we have an IOU of 0. Okay, so IOU is basically an evaluation matrix that is used to measure overlap between predictions from the object detection model and actual ground truth. So in the red color, in this red color, like in the red color bounding box, we have the prediction from the object detection model, and in the green color, we have the actual ground truth. Okay, so you basically using IOU basically find the overlap. Okay, so IOU is mainly used in application related to object detection where we train our model to output a box that fits perfectly around the object. So IOU is basically used in object detection. So there we basically when we train our and YOLO V7 model on any data set, what our aim is to that our output bounding box should fit perfectly around the object. Okay, so like this is in the red color, I have the predicted bounding box, and in the green color, I have the ground truth bounding box. So whenever I train my YOLO V7 model, the output I should expect or I expect is that this red color bounding box should fit completely or perfectly around this green object or around this green bounding box. Okay. So here we have the formula for the IOU. IOU is equal to area of overlap divided by area of union. Okay. So in area of overlap, basically find the area of intersection. Okay. So detected box is basically the prediction I generate from the predicted bounding box generated by my YOLO V7 model. And this object is basically ground truth. Okay. So I basically find the area of intersection between this predicted bounding box, which is labeled here as detected box, and this ground truth bounding box, which is labeled over here as object. Okay, and in the area of union, we have the basically area divided by area of union, or basically combined area. So we have area of overlap or area of intersection divided by area of union or combined area. So the question might be coming in your mind, why we need to calculate IOU? Why we need IOU? Okay, so intersection over union is calculated to measure the accuracy of object detection model. Plus we use IOU, intersection over union, in non-max suppression as well. In the next lecture, we will see what is non-max suppression. Okay. So in non-max suppression, we also use intersection over union. When you basically in the next lecture, when I will explain you the concept about non-max suppression, there I will also be using the IOU as well. So IOU, intersection over union, is a good metric to tell you which object detection model is giving better results in terms of accuracy. So using IOU, we basically calculate the accuracy of object detection model. So if I have trained multiple, like I have trained YOLO V5, YOLO V7 or YOLO V8 model on the sense plate data set. So through using IOU, I can IOU intersection of union can tell me which model, like either YOLO V5, YOLO V7 or YOLO V8, is giving me best results in terms of accuracy. So now we will implement intersection over union in Python and see what basically is intersection over union is. So first of all, I'm just importing all the required libraries. Import CV2 to implement PyTorch. We use Torch library. Then we have import matplotlib library to plot any image or in input image in the Google Colab notebook. So to plot any image in the over here, I will be using the matplotlib library. Okay. So plus now here I've just created a function by the name read annotation. So it will read annotations from the text file line by line. Okay, so the main purpose of creating this function is to read annotation from the text file line by line. Okay, so I have just placed the ground truth annotation file onto my drive, and I am just directly downloading this annotation file from the drive into this Google Colab notebook. Okay, so I am just downloading the annotations file, ground truth annotation file from the drive into this Google Colab notebook. Plus, uh, I have also placed the annotation of model A, which you can see that the model A is, for example, our YOLO V5 model. So I'm just downloading the annotations of generated by the YOLO V5 model labeled here as model A from the drive directly into the Google Colab notebook, and in the model B is basically our YOLO V7 model. So the YOLO V7 annotations are saved. The YOLO V7 annotations are saved in model B.txt file. So I'm just downloading the model B.txt file from the drive directly into this Google Colab notebook. So groundroot.txt, model A.txt, model B.txt, all these files contain the annotations. Okay. And using this read dash annotation function, I will read the annotations inside this .txt file line by line. So in the annotation which we have in the ground truth model A, model B .txt file, I will read all these annotation line by line using this read dash annotation function. For example, if I just want to read the annotations in this ground truth.txt over here, which I have downloaded from the drive into this Google Colab notebook. So just click over here, copy path, and just paste this path over here. Okay, so now you can see over here, these are the annotations which I am reading from the basically reading from the .txt file. Okay, so these are the annotations, but they are not properly processed. Okay, like we need to process these annotation, and we need to convert this annotation into the required format as well. Okay, so basically to convert these annotations into the required format, first, like you can see over here, we have this from here first, and this is our second annotation, and this is the class name. Like last is basically the class name, and these are the x1, y1 coordinates of the bounding box, and these are the x2, y2 coordinates of the bounding box. And for example, this is for the cat, and this is for the dog. Like this is the x1, y1 coordinates for the dog, and these are the x2, y2 coordinates for the dog. So first of all, using this line dot split, I will just split these two annotation using this comma, which you can see over here. Then I am just replacing this dash and basically slash n for the new line. We have slash n for the new line. So I'm just replacing this slash n with empty space, and then I'm just need this first four annotations like 1, 2, 3, 4. I just need this four annotation. I don't need the class number. I don't need this 0, 1 class number. 0 is for cat and 1 is for dog, but I don't need this currently. I just need this four annotation values. This is the x1, y1 value coordinate value, which is the top left corner, and this is the x2, y2, which is the bottom right corner. This is the x2, y2 coordinate value. So if I can just the image over here, let me just show you. Like you can see that this is the x1, y1, and this is the x2, y2. Okay, so if let me just navigate my screen and show you what I have. Okay, so now let me just tell you, like, for example, if we have this, we have two bounding boxes over here. This is the number 1, and this is the second bounding box. Okay, so if we see over here, this is the x1, y1 coordinate, and this is the x2, y2 coordinate. Okay, and similarly, this is the x1, y1 coordinate, and this is the x2, y2 coordinate. Okay, so if I just go back to the code, okay, so you can see over here, these are the x1, y1, and this is the x2, y2 coordinate for the cat, and this is the x1, y1, and this is the x2, y2 coordinate for the dog. So I just need these coordinates x1, y1, and x2, y2. I don't need the class name. Similarly, I just need the x1, y1, and x2, y2 for the dog. I don't need the class name. So just selecting the first four over here, and just saving all these basically annotations into this VBox, this VBoxes list which I have created over here. Okay. So just run this cell as well. So now I'm just downloading a sample image from the drive. Okay. So which I will use, I will be using this image for the testing. Okay. So when basically using CV2, when we read the image, it read in the format of BGR. Okay. So open CV Python or CV2 reads the image in the form of BGR. Okay. And basically, if you want to display any image using Matplotlib PLT, we need to convert that image into RGB format. Okay. So when we read the image, or if when CV2 read the image, it read in the form of BGR. And when we want to display that image using Matplotlib, we need the image in the format of RGB. So I'm just converting the image from BGR to RGB, and here is our image. You can see over here. Here we have a cat, and here we also have a dog as well. Okay. Okay. So basically now our annotations are saved in B boxes. Like you can see here in this function, I have just saved the annotation in B boxes. Okay. So now after we have the image over here, now to draw the annotations over here, I've just created a function by the name draw dash boxes, and in draw dash boxes function, I'm using cv2.rectangle to draw annotations around this cat or dog as well. Okay. So now, first of all, what I am doing is over here is I am just reading the annotations in this ground truth.txt. Then I using this process dash annotation function which I have created over here. Like I've just created a process annotation function to convert the annotations into the required format. Okay. Then basically using draw dash boxes function, in draw dash boxes function, I have, you can see here cv2.rectangle in the draw dash boxes function to draw the annotations around the cat and dog. So I'm just calling the draw dash boxes function to draw these annotations around the cat and the dog. Okay. So first of all, I'm drawing the ground truth. Then I'm drawing the model A predictions, and then I'm drawing the model B predictions. Okay. So now you can see that after we draw the annotations on the image, so now you can see that we have three different annotations on each on the cat as well as the dog. So now we can see that we have three bounding boxes on cat as well as on the dog. So if you now you can see that we have the bounding boxes color green, red, blue. Okay. So green color bounding box represent the ground truth bounding box. Like you can see over here, we have set the ground truth color bounding box color as green, and model A as blue, and model B as red color. Okay. And blue color bounding box is the model A predictions, and red color bounding box is the model B prediction. Okay. So if we see that green color bounding box, it basically represent the ground truth bounding box. So now we can see that the what basically our aim is in when we train our yellow v7 model on any custom data set, our aim is that our predicted bounding box should be as close to the ground truth bounding box. So green color is the ground truth bounding box. Okay. So if we see over here, our red color bounding box is the model A prediction, and blue color bounding box is basically red color bounding box is basically model B prediction, and blue color bounding box is basically model A prediction. Okay. So as our goal is that our predicted bounding box should be as close to the ground truth. So now here we can see that this red color, which is basically model B predictions, red color bounding box is basically model B predictions. Okay. So you can see that this is close to the ground truth bounding box. So this red color bounding box is close to the ground truth bounding box. Okay. So we can see that broad color bounding box are better fit than blue color bounding box and are more close to the ground truth. So now here we can also see that red color bounding box is more close to the ground truth than blue in the case of cat as well. So now we are just converting these annotations to PyTorch tensor format, which I am just converting the ground truth model A and model B annotations into the PyTorch tensor format. Now basically we need to calculate the area of intersection. Okay. So to calculate the area of intersection, we need corner coordinates for the intersection area. Okay. So what I mean by this, basically to calculate the area of intersection, we need corner coordinates for the intersection area. So now that I have told you, IOU formula is equal to area of overlap divided by area of union. Okay. So these are the x1, y1 coordinates over here. these are the x2, y2 coordinates for this bounding box, ground truth bounding box. And for the predicted bounding box, which is labeled as detected box, these are the x1, y1 coordinates, and this is the x2, y2 coordinates. Okay. So using this, if we just write this over here, like this is my x1 and this is the x2. Okay. So now you can see here, we have the 2 over here, and then we have the 5 over here, and this is my y1. Okay, over here, and this is my by1. So I have just written 1 3, and now you can see that for this predicted bounding box we have the x1 x2. So if we just write here 9 13, and this is the y1 y2 9 7 and 9, we can see over here these values as well. Okay, so now here you can see that I have just created a function by the name calculate IOU. So here you can see that 3 dots. Okay, so we use the 3 dots when we basically want to transform only one dimension. So we use the 3 dots when we just want to transform only one dimension and want all others to remain same. Okay, so the 3 dots will be used when we just want to transform one dimension and want others to be remain the same. Okay, and here I'm just using this max formula, which I have explained to. This max formula and min formula is being used over here. Max min formula I'm just using. Okay, and now I'm just calculating the area of intersection. So area of intersection is length multiplied by breadth. Okay, and here I'm just using clamp 0. Clamp 0 is used to handle classes where there is no overlap or intersection. Okay, so clamp 0 is just used to handle cases where there is no overlap or intersection. Okay, then I'm just doing the predictions area and labels area. Okay, so now here, as we know that area of IOU formula is area of overlap or area of intersection divided by area of union or combined area. So in the area of union, we have the predicted area plus label area minus area of intersection. So I'm just minusing the area of intersection in the area of union, so that it should not be added in the area of union when we are just calculate the area of union. And then I'm just returning the area of intersection divided by area of union, which is giving me the IOU. Okay, so if I just calculate the IOU for the model A and the model B as well, so now we can see that using model B we are getting better results. Okay, so if we see over here, so red color bounding box is the model B prediction. Okay, so now we can see that model B is represented over here by red color. Okay, so model B is represented over here by red color, and it's already very close to the ground truth. So it will definitely have a better IOU. While blue color bounding box is far away. Blue color bounding box represents the model A. Okay, while blue color bounding box is far away from the ground truth, and it will definitely have low IOU. Okay. So we can see that as red color bounding box, which is model B, is close to the ground truth, so it has a better IOU, while blue color bounding box, which is presented by model A, is far away from the ground truth, and so it has low IOU than model B. So that's all from this video tutorial. See you all in the next video. Till then, bye bye.